Let us discuss three modeling styles which are popular as far as VHDL programming is considered. First one is called behavioral, second one is structural, and third one is data flow modeling style. So let me first of all discuss with data flow modeling style. Uh, Data flow style describes the system in terms of how data flows through the system. Data dependencies in the description match those in a typical hardware implementation. That is important. Data flow description directly implies a corresponding gate level implementation. Data flow description consists of one or more concurrent signal assignment statements. And as the name indicates, since this particular modeling style is reflecting the flow of the data, so using wait statement or different forms of wait statement like wait after, wait on, wait until, or even simple after clause, we can control the flow of data by inserting wherever required some time delays or some timing related things if we want to add and control as far as operational say decision making is considered, or maybe the expected concurrency but from some other timing aspect point of view, then this modeling style can be used. This small example, say for example half header we have designed. So this is your library declaration and package declaration, then entity half header is port a comma b in std logic. Say for example sum and carry out is your out std logic because this is input and output. And in architecture, simply we have written two statements, that is sum is assigned equal to ax or b, carry is assigned equal to a and b. Now this is the plain data flow style. Say for example if you want to add here some timing related statement like show the carry or output after some duration, that is after some interval timeout as sum, then you can insert here. Then second style is behavioral style. The behavioral description describes the system's behavior or a function in an algorithmic fashion. Behavioral style is the most abstract style. The description in abstract in the sense that it does not directly imply a particular gate level implementation. That means you can use your truth table or any other thing. Behavioral style consists of one or more process statements. Each process statement is a single concurrent statement that itself contains one or more sequential statements. Sequential statements are executed sequentially by a simulator, the same as the execution of sequential statement in a conventional programming language. Now the same half adder you can see here, like half adder. Here we have done all that declaration part, same architecture behavior of begin, then half adder process a comma b, begin if a is equal to 1, then sum is not b, carry out is b as it is, else sum is equal to b, carry out is equal to 0. So these two statements like if else we have used here. Process is a sequential statement. Now one more thing here, in two statements this has been done. Instead of that we can write as if a is equal to 0, b is equal to 0, sum is equal to 0, carry is equal to 0. Then else if a is equal to 0, b is equal to 1, sum is 1, carry is 0. Else if a is 1, b is 0, sum is 1, carry is 0. And else last clause we can write as if a is equal to 1, b is equal to 1, then directly we can write sum is equal to 0 and carry is equal to 1. So in that fashion, as an OR gate implementation, no doubt one we can write there, but in general just I'm telling. So we can, as whatever is our truth table considerations, not necessarily for half adder, in general I was just trying to tell you. So that way we can implement here truth table. So this is behavior modeling style. Then the third style is the structural modeling style, where entity is described as a set of interconnect components. The top level design entities architecture describes the interconnection of low level design entities. Each lower level design entity can in turn be described as an interconnection of design entities at the next lower level, and so on. Structural style is most useful and efficient when a complex system is described as an interconnection of moderately complex design entities. This approach allows each design entity to be independently designed and verified before use in the higher level description. whatever these statements are actually reflecting theoretically, same thing you can see here just in the program, same half adder program. In half adder we have used one XOR gate and one AND gate. So whatever we mentioned in this just the description, that set of interconnected components, same thing is done here. These are two components, one is XOR gate, another one is AND gate, and this is called component instantiation part, where in the beginning, after architectural declaration, we have to define two components, then main begin of our architecture, and these two components are instantiated here. This is little different concept, like we in conventional programming we say function is called, then in some hardware based approach we say that service is invoked, function is called, service is invoked. Same style in HDL we call component is instantiated. So that is a slight difference, because it is going to get appeared there itself wherever it is that interconnection is done and wherever we are going to use it. So that's why the syntax is label you have to give, then the component name, then port map, and the binding you have to show. So like in XOR gate I1 I2, here it is A and B. So A and B to that XOR gate, sum is to O1, that is the output of XOR gate, and same fashion for AND gate I1 I2 to A and B, and carry out is to O1. And then there may be this way you can write down the component map, and finally this U2 you can have an AND gate port map A, B and carry out. This way also you can mention directly. So this is like a positional association which we call. So this is one statement like U1 XOR gate port map A, B and sum, and U2 AND gate port map A, B and carry out. Here the respective position plays very important role. So automatically there is no need to use such binding operators or assignment operators. Instead of that, directly if I write here A comma B comma sum, then by default whatever is XOR gate component in that component port map, that is input and output, sequentially those will get positioned and assigned. So this is another style of interpreting as far as structural modeling is considered. So in short, data flow is the view of data flow through design from input to output. An operation is defined in terms of collection of data transformation expressed as concurrent statement. In case of behavioral, the functional or algorithmic aspects of design expressed in sequential VHDL process may be truth table based directly. The view closest to hardware, a model where the components of design are interconnected. The view is expressed by component instantiation. In case of data flow, it is a set of concurrent statements, especially behavioral. Most of the times it is a set of sequential program statements, and in structural it is a set of interconnect components. In data flow, logical equations are there. In behavioral, binary numbers, some sort of truth table based approach used to be, and in case of structural it is actual hardware which is interpreted with the help of interconnection of gates. Then in data flow represents behavior. Behavior also it represents behavior, but structural explicitly it gives you an idea about the actual structure with the help of the building blocks or components. Data flow involves structure. Behavior cannot contain structure information. Like we can directly write a truth table and directly write a program with some statements from VHDL. So it will not be directly telling you any kind of information related to hardware structure. Then in case of structural probability, that there will be a kind of a hierarchical manner, the entire hardware will be in indirectly it is as if interpreted, or somewhere directly also some components they will directly reflect the actual structure of the hardware. In case of data flow, level of abstraction is in algorithmic fashion. Here it is gate level in behavioral, and in structural it is register transfer level. Required Boolean equations as design specifications in case of data flow. So if direct equation is given, we can have assignment statements and we can directly use concurrent statements. With the help of them, we can have our logic. In case of behavioral, we require truth table or state table, which will directly reflect how exactly is the function and how the that system is behaving. And in structural, we will be having logical design. That means actually we must know how exactly it works, and we have to think hardware a little bit in more detailed way as far as structural modeling is considered. Thank you.